Welcome to session 33. Today we cover circles. Every circle question on the SAT is built from a small set of formulas, so once you know them and read the setup carefully, these become some of the most reliable points on the test. By the end, you will use the area, circumference, arc, and sector formulas. Read a circle's center and radius straight from its equation, and apply the inscribed angle and tangent theorems. Let's begin with the two formulas everything else rests on. The radius r is the distance from the center to the edge. The area inside the circle is pi times the radius squared. The circumference, the distance all the way around, is 2 pi r, which also equals pi times the diameter. See how they connect. If the circumference is 20 pi, then 2 pi r equals 20 pi, so the radius is 10. Now, the area is pi times 10 squared, which is 100 pi. And remember, every one of these formulas uses the radius, not the diameter. Next, a slice of the circle. A central angle theta cuts out an arc along the edge and a wedge-shaped sector inside. The arc length is the fraction theta over 360 times the full circumference, 2 pi r. The sector area uses the same fraction times the full area, pi r squared. Take radius 6 and a central angle of 120 degrees. That fraction is 1/3 of the circle. So the arc is 1/3 of 12 pi, which is 4 pi, and the sector is 1/3 of 36 pi, which is 12 pi. Every time it is just a fraction of the whole. Circles also live on the coordinate plane. A circle is just every point a fixed distance from its center. In standard form, that is x minus h squared plus y minus k squared equals r squared. The center is h comma k, and the radius is r. But watch the signs. A plus 3 inside means h is -3, because plus 3 is the same as minus -3. So for x minus 4 squared plus y plus 1 squared equals 36. The center is 4, -1, and the radius is the square root of 36. Sometimes the equation is scrambled into general form. To find the center and radius, we complete the square. Start with x squared plus y squared minus 6x plus 4y minus 12 equals 0. Group the x terms together and the y terms together, and move the constant to the right. Now complete each square. Half of 6 is 3, squared is 9. Half of 4 is 2, squared is 4. That factors into x minus 3 squared plus y plus 2 squared equals 25. Read it off. The center is 3, -2, and the radius is the square root of 25, which is 5. Finally, 3 theorems the SAT loves. First, an inscribed angle is always half of the central angle that cuts the same arc. Second, Thales' theorem. If a triangle's longest side is a diameter, the angle across from it is a right angle. Third, a tangent line touches the circle at one point, and there it is perpendicular to the radius. That right angle is the key to most tangent problems. Here is the setup. From an outside point P, draw the tangent to point T and the radius OT. Those meet at a right angle, so OT and P form a right triangle. If the radius is 5 and the distance OP is 13, then PT is the square root of 169 minus 25, which is 12. It's the 5, 12, 13 triple again. Your turn. A circle has a radius of 9 and a central angle of 80 degrees. Find the length of the arc it cuts off. Pause the video and work it out. The fraction is 80 over 360, which simplifies to 2/9. Multiply that by the full circumference, 2 pi times 9, or 18 pi. 2/9 of 18 pi is 4 pi. Let's recap session 33. Area is pi r squared, and circumference is 2 pi r. Arc length and sector area are both a fraction of the full circle, theta over 360. A circle's equation, x minus h squared plus y minus k squared equals r squared, hands you the center and radius directly, and completing the square gets you there from general form. Finally, an inscribed angle is half the central angle, and a tangent is perpendicular to the radius.